Okay, welcome to video number 1. We are less than a week out of the Extension 1 2019 HSC, and I've come up with 10 videos that I need to make. These ones are going to be quite short though, and it's just a very brief summary to help you with 10 parts for the 70 marks. So there's 10 parts of the HSC and if you can get each one of these parts that I've split up into 10 videos, you're well and truly on your way to getting the full 70 marks. So it's just about having a really good understanding of your basics and then practicing them more and more to get that deep understanding. If you have the basics down pat and can develop that deep understanding, you can easily get your 70 marks. Alright, so these are the 10 pieces that I've split it up to. So today's video is starting with polynomials. Now, these are just 10 things, and it covers most of the course, but I sat down and I looked at the past 8 years worth of HSCs, and I looked at what they ask every single year, what they never miss, and what's always in there, and worth quite a few marks. And this is what I've come up with. So I think you'll find that in the last 3 years in a row, I think it was, polynomials was the first question in the HSC. So today's video is on polynomials. The first thing is just knowing that your most common is your cubic, and it's written in this form. Now, we can factorize the cubic into what we call a of x times in with q of x plus in with r of x. So it's a factorized form of the original cubic. We call a of x the divisor, q of x is the quotient, and r of x is the remainder. Okay, so when you multiply a and q together plus r, you should get the original polynomial. There's two big theorems you do need to know well. You got your remainder theorem, and that's just knowing that if you divide a polynomial by a certain factor, the remainder is subbing that factor into your original polynomial. So for instance, if you divide a polynomial by x minus 2 with long division, the remainder you will get out is if you did sub in 2 into your polynomial. And the last one is the factor theorem, okay? And the factor theorem just says that if you sub in a value into your polynomial and it comes out as 0, then that is a factor, that value. So I've just done some pretty generic questions here. Two common types of questions. The first one is just finding the factors, and this sort of opens up a range of ways they could ask that question, so you'll see what I mean in a second. And the second one is bringing in some sort of value of k, which stumps a lot of people. Everyone sees this k value and gets confused, but they're still very straightforward questions and yet very common. So let's have a look at this first one. So we want to find the factors, okay? So basically we want to factorize this polynomial so that we can write it in some sort of form with p of x, a of x, q of x, and r of x. So the first thing we do to find some factors is you test some points. You test p of 1, and usually testing values around or near 0, you will get it. Usually if you can see straight away whether 0 is going to be a factor or not, because if it has a constant on the end, it's not going to. But just subbing in 1, -1, 2, -2, maybe 3, -3, but that's a lot more work than needs to be. One of them is generally a factor. So I'm just going to be putting these values into my polynomial and seeing what I get. So subbing in 1, I didn't get 0, and you don't have to show them what you get when you sub it in, you just have to show whether it is or isn't 0. So therefore 1 wasn't a factor. But when I subbed in -1, it did equal 0, so therefore it is a factor by the factor theorem. So I don't have to worry about the others. So something I would write is a therefore statement. So therefore p of -1 is 0, so therefore it is a factor by the factor theorem. Okay, now I found technically that's a root. To write that as a factor, remember we do the opposite sign. So x plus 1 is a factor. Now I have one factor. I can find every other factor and write it in that form that I want by just doing long division. So So I'm just going to take my polynomial and divide it by x plus 1. Okay, so if you know your long division well, then skip ahead. Otherwise, I will just go through how to do it. For those who do get confused with long division or you haven't quite mastered the skill, you're best to make a summary on the steps and then do 3 or 4 questions following that summary. Then take the summary away and do 3 or 4 more questions, and you will get the hang of it very quickly. Okay, so let's have a look at this. The first thing I do is I say x goes into x squared times. In other words, x times by what would give me x cubed, and that's x squared. Now I multiply my x squared by both of these terms. So I get x times x squared is x cubed plus x squared when I multiply that in. Now I put my line in and I subtract. When I subtract, I'm going to put a nice big negative sign to keep me remembering and not to get mixed up with my negatives. Now this should cancel. X cubed minus x cubed, yep, that cancels it out. Negative 4x squared minus another x squared gives me negative 5x squared. Now this is the value I start again with. I say x times by what will give me negative 5x. So that's going 5x squared, sorry, is negative 5x. And now I do the same thing over again. I times this in here by both of these terms. Negative 5x times by x will give me negative 5x squared minus 5x. Now this is where I bring my new term down. I bring in my plus x. And I put my big subtraction and I cancel. They should always cancel out. If they don't, something's gone wrong. So negative 5x squared plus another 5x squared is going to give me 0. And then x minus negative 5x, notice the double negatives, is going to give me 6x. Alright, now here's my value once again. Sorry, so I go again. I'm going to say, okay, x times by what will give me 6x, that's a positive 6, and now multiply it in. I'm going to get 6x plus 6, bring down my 6, make my subtraction, and I get 0. Now, of course I should get 0 because x plus 1 is a factor. If you don't get 0 there and x plus 1 is a factor, something's gone wrong. You should have got 0 because we've already established that x plus 1 is a factor. However, now I can make this step. Now I can say, well, therefore, p of x is really going to be x plus 1 timesing with x squared minus 5x plus 6. Because if I take my polynomial and divide by x plus 1, I get that value. And my remainder for this case is plus 0. So now I've written it in that form from above. The question though I wanted was what were the factors. So I had a factor of x plus 1, and now I have another factor of x squared minus 5x plus 6. You should always check to see if that other value can factorize. So I will have a look, and it looks like it does. 2 negatives. So therefore they are all my factors of my polynomial. If they wanted the solutions or the x values, then it would be x equals negative 1, 2, or 3. Okay, so depending on what the question asks, and that's why I put that question in there, because it's such a broad question on what they could ask. They could just ask you to divide the polynomial by something, and I've shown you how to do that. They could ask you what the factors are. I showed you how to do that. They could ask you to write it in the form p of x equals a of x, q of x plus r of x. I've shown you that. Or they could ask you what the solutions are, or the x values are, the x-intercepts are, and I've shown you how to do that. So it's a really open-ended question, but just know how to do that, how to get to all those steps and apply it to what they do definitely ask you to do. Alright, the other side here we have find the value of k if we have this polynomial and it has a factor of x minus 2. So if that's a factor, that tells me that when I take p of negative 2, by the factor theorem, it should equal 0. So don't be afraid by questions like this, just use your knowledge of it. Which means that if I sub in -2, I should get that equaling to 0. So I sub in my -2 and I solve it for x because I know that they told me it's a factor, so it has to be equal to 0. And I'm just going to solve that now for x. So there's my value of k. Oops. 36. Alright, the last part of polynomials that is commonly asked, perhaps not as common, but just still something to know, are your roots and coefficients. And they're really straightforward. They look confusing, but they're really not. So, you should know your advanced level roots and coefficients because they're super easy. But the cubic ones can be a little bit tough. The green boxes there are what you get as a formula on your reference sheet. You just need to be able to find each one of these things. I'm not going to go into the 2-unit versions. You should know how to do that already. But let's have a look at how you would find the 3-unit versions. Notice I haven't got a specific equation here that I want you to find the root value. I'm just going to show you how you can adapt these questions to fit into the formulas. So straight away, something like this. All you're going to do is expand it. Now expanding 3 brackets, I'm just going to ignore the third and expand both of them to start with. So foiling that out and writing what you get. Again, don't try and skip steps, take your time with it. Once you have that answer, I say to myself now, okay, now that was timesing with my gamma minus 1. And now, do the exact same thing, foil it out. There's just a few more things to foil out this time. So this is what you should get if you carefully have expanded those out. And again, you can do little things like check how many things you should have. So there's 4 terms in here and I've multiplied it by 2 things, so I should have 8 terms, which I do, just to make sure you haven't missed any. Now I'm just going to gather some things together. I say to myself, well, I know the formula tells me a value for alpha, beta, gamma. So that's that part done. The formula also tells me when they're all multiplied by each other. If I factorize out a negative out the front of this term, and this term, I should get exactly, now that's supposed to be negative, isn't it? Yes. What's the formula gives me? Which I do, which is C on A. And lastly, all that's left is a gamma plusing with an alpha plusing with a beta and a -1. Which again, the formula gives me that part, and then minusing 1. So then you would just sub the values in. You'd have negative D on A, minusing with C on A, plusing with negative B on A, and then subtracting 1, depending on the question. So it's all about just adapting them to be put into the form that we know in our given. Alright, the fraction 1. I'm just going to get the same denominator. How do I get the same denominator? I multiply it by what it doesn't have. This one doesn't have a beta gamma. What I multiply the bottom by, I have to multiply the top by. This one doesn't have an alpha gamma, so times the top by it. And this one doesn't have an alpha beta, so I times the top by it. And now I'm left with beta gamma on alpha beta gamma. I'll write it as one big one plus alpha gamma plus alpha beta, which again are your 2 formulas you get given up here. So it's just about then subbing it straight in. Okay, this last one. The trick we want to be able to do is say, well, is that the same thing as alpha plus beta plus gamma? Very similar to the 2-unit version. You say, well, I don't know, is that the same thing? You should know it's not. Well, let's have a look at what we do get if I did expand this out here. Okay, so if I expanded that out by foiling, what do I get? So what I have here is what I actually got when I expanded it out. So I, once again, very carefully expanded that out, knew that I needed to have 6 terms, and I had 6 terms, factorized some things together. Now again, the formula tells me how to equate this. Hang on, sorry, what have I done here? Yes, so what I can say now is that, well, I know that alpha squared plus beta squared plus gamma squared, plussing with a 2, lots of alpha beta plus alpha gamma plus beta gamma, sorry my gammas aren't very good, is equal to putting all that squared. So then I can say, well, therefore alpha squared plus beta squared plus gamma squared is equal to all of that squared minus 2 alpha beta plus alpha gamma plus beta gamma. And there we have it. I can now equate what this is by doing this formula, squaring it, minusing 2 times by that formula. So once again, it's just about being able to manipulate those formulas into something that we know or are given in the equation. Okay, hopefully this video helped, and stay tuned for video number 2, which will be on integrating powers of trig.